Hello, good morning, student. How are you? You might be fine. As you know that the previous lecture or in the last lecture we have learned about protection and the deprotection, why protection and deprotections are necessary or important, or what are the significant for the protection and the deprotection that we already seen at the introductory part. Because one protection means what? The functional group modification is known as a protecting group. When we are protecting, the reactivity of that particular functional group is decreases, whereas the rest of the functional group, it is a reactive, so that we can treat with the proper reagent and the conversion takes place suitably, and we will get the desired product. So that is a main object or main aspect of this protection and the deprotection. And also we have seen the ideal protecting group. Ideal protecting group means what? Number one, ideal protecting group means the group should be introduced under mild condition. Number two, the protecting group should be removed under mild condition. And number three, the protecting group should be stable under acidic condition or basic condition or neutral condition during the necessary transformation of the reaction. So that are the main thing required for the ideal protecting group. Last time we have seen we are talking about the protecting group of carboxylic, protecting group of alcoholic group or the hydroxyl group OH. And now today the fourth one, first one I think we have seen as a alkyl halide, or we can use as a benzyl as a protecting group, or we can use as a PMB, para-methoxy benzyl chloride as a protecting group. We are getting as a ether. Why ether? That reason also we have learned about that. Now let us look at as a trityl chloride. What do you mean by the trityl chloride? What is the structure of trityl chloride? So now there, suppose let us see, fourth one is a trityl chloride. Trityl chloride, that is a protecting group as a ether, so it, and in short it is written as TrCl, or we can call it as a PH3CCl, means triphenyl methyl chloride, or chloromethane we can call it. So that is the thing. And if you take the general reaction, we know that hydroxyl group OH, this is a general formula of alcohol, or ROH, may be as a alkyl group or the acyl group, and this trityl group is introduced under basic condition, whereas it is removed under acidic condition, and it is a stable under basic as well as neutral condition. And therefore here this will be treated with PH3CCl in presence of base. You can use as a pyridine as a base, and what do you get? R protecting alcohol RO, then CPH3, that group get protected over there. And now further, this is a protection into this protecting group is introduced under the basic condition and it is removed under the acidic condition. If you use as a H plus, what do you get? The alcohol is regenerated and we are getting as a side product, maybe as a this one. Don't think about that one, but we are getting our original starting material functional group is as it is. So that is called as a protecting via trityl chloride. We are getting as a ether there. Now let us look at as a mechanism here. Mechanism of protection. Mechanism of protection here. ROH, here base is used as a pyridine, PY. It will and I know that you are knowing the structure of the pyridine. Are you knowing the structure of pyridine? Yes, you are knowing. So let's see, pyridine is a base which will abstract the acidic proton, and RO minus oxygen atom is more electronegative in nature. When this bond is broken heterolytically, both the bonding electron resting on that oxygen atom and therefore negative charge on it, and then further treated with this one PH3C, then Cl. What is happening? This negative charge attacking on that carbon atom, departing as a chlorine atom, and we are going to get here RO, then CPH3. That is a protecting alcohol. That is, and this is a mechanism of protection. Now let us look at the mechanism of deprotection. Mechanism of deprotection. So now let us take that compound once again, RO, then C, here PH3, that will be treated with in acidic condition. What is happening? Lone pair which is present on that oxygen atom will pick up the proton, and we are going to get R, then C, R, then O, H, then CPH3. Now look at here, what do you see here? There are the 3 bonds of oxygen atom, and therefore positive charge comes on it. When positive comes on it, that species becomes as unstable. It trying to become as a stable. So this bond is broken like this, and we are going to get as a alcohol ROH and plus, that is CPH3, that is a tertiary carbocation is formed here. PH3, that is a highly stable. It can pick up the proton from maybe as a solvent OH. We will get as a tertiary alcohol type of the main thing is this one. So where should be where it is useful in the this kind of the protection, where it is used, that we are going to see. While the synthesis of the nucleic acid, this type of the protection is required for the synthesis of nucleic acid. Let us look at here the main application of this group for the synthesis of nucleic acid. Synthesis, for example, synthesis of nucleic acid. So while synthesis of the nucleic acid, this type of the protections are useful, and that's why, because that trityl chloride, that is a very bulky group. So let us look at here is a one of the structure OH, then here OH, then maybe here nitrogen atom, then 5-membered ring here, maybe as a nitrogen one over here, one here, sorry, 6-membered ring, then NH2 double bond, then here maybe as a H double bond, double, not this, I think one double bond, maybe here or double bond here, 5-membered ring, H is there, so that becomes as aromatic, or this part is known as a sugar and this part total known as a base. Now look at, there are the two hydroxy groups are there, and this hydroxy group here is this is a primary hydroxyl group and this is a secondary OH group. Now when it is treated with trityl chloride, that is a TrCl, in presence of pyridine Py. Pyridine, the function of pyridine base which will abstract the acidic proton which is attached to oxygen atom, and the resulting compound it is not going to attack on that OH because it is a bulkier than this one. This is a primary alcohol, this one is a secondary alcohol, and so trityl chloride specifically protect the primary alcohol. It is used for the protection of the primary alcohol. So what do you get here? You are going to get here the product is this one, O, then Tr. In short we can write this one, and therefore here is a OH, and this in short I am writing that is a TH, that is a thymine is there, so we can write as a TH. Now it is further treated with acetic anhydride in presence of pyridine. What you are going to get here? You will get here this product. There is a TH, you can write in short, and then there will be OTR, that is a trityl is a protecting group, and here O and COCS3. This type of this compound also get protected. Now then you can treat this compound in presence of the mild acidic condition. What is going to happen? The bond is going to break between this, and you are going to get as a final product maybe as OCOCS3. Then here we are going to get as this type of the product, and further you can treat with another phosphate, so we will get as a phosphorization. So this is the main purpose of that trityl chloride. It is a bulkier group. The reactivity of this hydroxyl group is decreased, and that's why we are going to get as here is a protection of this, and we can deprotect it. You will get our desired product. To get the desired product, and that's why it is used as a protecting group. Now let us move on to the next one, that is a tertiary butyl protection. Now what do you mean by again as a tertiary butyl protection? That is also used while the synthesis of the nucleic acids. So let us see another protecting group, that is a fifth one, that is a tertiary butyl protection. Now tertiary butyl protection, let us see as a general example here. As we know that ROH, that will be treated with this one butane in presence of the H plus. What do you get here? You will get here RO, then this one tertiary group. This is further treated with deprotection also occur in the acidic medium, and what do you get? Introduced under the acidic condition and removed under the acidic condition, so that we are going to get as a ROH. So this is a general protection and the deprotection reaction of this alcohol with the tertiary butyl as a protecting group. Now let us look at as a mechanism. Now the protection, we introduce the protection under the acidic condition, whereas removed under also as a acidic condition. And this way, while carrying carry out this transformation, and during that process it is stable under basic condition as well as oxidation as well as reducing oxidizing and the reducing reagent we are going to, it is highly stable, and so it doesn't affect these reaction and so forth, so that we can easily get the desired product here. Now let us look at as a mechanism of the protection. Mechanism of protection. In the mechanism of protection, what is happening here? This is a alkyne or 2-methyl 1-propene that will be treated with in an acidic condition. So H plus, this double bond moving, attacking on that H plus, you are going to get the product. This is a tertiary carbocation, and these tertiary carbocations are highly stable, and we know that the stability order of carbocation, tertiary carbocation is more stable than secondary than the primary, and therefore, and that will be treated with alcohol ROH. So this is going to attack over here, and therefore we are going to get RO, then this tertiary group. That is a simple mechanism of the protection. Now look at the mechanism of deprotection. Mechanism of deprotection, let us take down that example once again. RO, then then this is our tertiary group, tertiary butyl group, then that will be treated with, in presence of the H plus, the lone pair which is present on the oxygen atom attacking over there, you are going to get RO, here is a H plus, and then here C, here you can write as a, this is our tertiary group. Now there are the 3 bonds are there, that becomes as a positive charge. When the positive charge comes on that oxygen atom, that species becomes as a highly unstable, it trying to stabilize it, and therefore there are the 3 hydrogen. I am showing only as a 1 hydrogen atom so that you can clearly see the mechanism. For mechanism purpose, that sigma bond forming as a double bond over there, and this bond is breaking here, so that we are going to get, here is ROH, and the side product whatever we have taken as a starting, that is tertiary that is alkene, we get back. So this is the protection of tertiary butyl of the alcohol. This is and this is also used in the synthesis of nucleic acids. Now let us move on to the next point, that is protection as an ester. Means alcohol will be protecting but as an ester. That are the point we are going to discuss here. Now let us see protection as ester. Protection as ester. Protection as ester, there are the various reagent we can use there for the protection. So main thing, 2 step you must be remember: introduction at what condition and removed at what condition. These are the main thing required for the protection and the deprotection. Now let us look at here first one, A, that is a sub. Let us take down as a general formula of alcohol is ROH, that will be treated with AC2O, or what we can call, you can use as a ACCl. So what do you get? You are going to get the product is a RO C double bond O CH3, or we can write this compound ROAC. AC means acetyl group. So we can write this manner, and now this is a further treated with base you can use as a pyridine, or maybe as a what we can call it as a K2CO3, sodium carbonate as a weak base, so that we are going to, or you can use as a here aqueous sodium hydroxide in presence of methanol or any alcohol, what do you get? The compound we are going to get as a alcohol. So that is the simplest. Now the mechanism, how the mechanism of this reaction takes place. Let us see first one. Suppose we have a mechanism of protection. Mechanism of protection here ROH that will be treated in presence of the pyridine. So pyridine, which is a base which will abstract the proton, and you will get RO minus, and that will be treated with acetic anhydride. As you know that the structure of acetic anhydride is like this: CS3, negative charge attacking on this carbon atom. This bond is moving in this fashion, and the compound we are going to get here RO C double bond O CS3, that is as an ester, and it is a further let us look at as a mechanism of deprotection. Mechanism of deprotection, what do you get here? Let us take down this example once again. RO C double bond O CS3 in presence of aqueous sodium hydroxide and methanol used as a solvent here. What is going to happen? OH minus, which is attacking on this carbonyl group, this bond is moving like this, and here the product we are going to get ROH, as well as side product maybe as a acetic acid CS3 C double bond O and OH. So this is a simple mechanism for protection as well as deprotection. Now if you look at the other reagent which is there, they are showing the similar mechanism because they are introduced in a basic condition as well as removed in the basic condition, and they are very stable in a neutral condition as well as in a acidic condition. And now let us look at second one. Now let us see the second one. Second one is a formate ester. B is a formate ester. Formate ester. Now we know that the general formula of alcohol is a ROH, that will be treated with formate ester, formate anhydride C double bond O, then O C double bond O H, that is called as a acetyl formate or acetyl anhydride, and that is treated with pyridine. What do you get? That is, look at here, there are the two carbonyl groups are there. This one is more reactive than this one, and therefore it is going to react like this, so that we will get H, that is a formate ester. This is a formate ester, this is a formate anhydride, and now this will be treated with this one, treated with base like as aqueous sodium hydroxide in presence of methanol. The resulting compound obtained is a ROH and plus suppose as a H C double bond O OH, which is a formic acid. So this is a simplest mechanism we already seen in the first example, so there is no need. Now let us look at as a third one, which is known as a third one, acetate ester. This acetate ester instead of here the general formula is the same, ROH CS3 C double bond OO. Here instead of this hydrogen atom there will be a methyl group CS3C double bond O treated in presence of the base. So what do you get here? Only changes I am making changes here only, you have to write properly here CS3. So that is a acetate ester here, I got acetate ester and further treated with aqueous sodium hydroxide in presence of methanol. What do you get? The alcohol is back, and instead of that hydrogen there will be a CS3 acetic acid, that is a side product obtained there, that is there. Now next one is a trichloroacetate. Here trichloroester, suppose is a trichloroacetate ester. So here just remember what will be the structure of trichloroacetate. So trichloroacetate Cl3 C double bond O Cl. So that is the structure of trichloroacetate, and the resulting compound we are going to get instead of this CCl3. So this is a trichloroacetate ester. This is a trichloroacetate ester further treated with the aqueous sodium hydroxide and the methanol. What do you get here? Again ROH, instead of hydrogen there will be a this one Cl3C, that is a trichloroacetic acid, that is a side product obtained there. So now let us move on. Next one, what is the next one? Last one, E, that is a pavelate ester. Now pavelate ester, and what will be the structure of pavelate ester? The structure of pavelate ester is similar to that trichloroacetyl chloride, like this. So here CS3, then CH2 methyl group 40 times, then C double bond O Cl. So that is the structure of pavelate acetyl chloride, and that pavelate acetyl chloride treated with pyridine, the resulting compound obtained is this one CH2 14 times CS3, that is called as a pavelate ester. This one is known as a pavelate ester, and this pavelate ester further treated with aqueous sodium hydroxide and the methanol, the resulting compound obtained will be this one ROH and plus this one CH3 CH2 14 times and C double bond OH. That is a maybe as a pavelatic acid we are going to get, and every reagent is introduced under the basic condition as well as it is removed under the basic condition, and they are highly stable in acidic condition as well as in a neutral condition. And now I think with this let us stop today here. Remaining protecting group of alcohol we will see tomorrow's lecture. So have a nice day. Thank you.